systems that keep the passengers alive. For manufacturers, speed means success, and their competition isn't cars, but aeroplanes.
For the train to be a big competitor for planes, you have to be able to do a distance of 1,000 kilometers in less than 3 hours.
That's France top to bottom, in half the time it takes on the road.
All the tests and all the experiments we made show that when you have a travel time up to 3 hours, you get almost all the passengers. Beyond 3 hours, of course, you still have traffic, but the airplanes come back. At 3 hours travel time, the share of the market for the TGV is something like 70–75%.
The TGV has a top speed of 320 kilometers per hour. That's a touch slower than the target. Alstom wanted to up the top speed for the AGV to 360 kilometers per hour. The secret to kicking up the top speed is all in how the power is distributed. Every high-speed train Alstom has ever made uses the electrical equivalent of a locomotive, called a power car. That's a dedicated train car for the motor, the power equipment, and of course, the driver. But there's a catch in that design. Each train needs 2 power cars, one in the front and one in the back. That's 2 full train cars of equipment where there could be paying passengers. So the designers came up with a revolutionary solution. Take away the power cars. Instead of having power concentrated at each end, it would now be distributed onto undercarriages called bogies, with motors built right in. This way, the train can have seats where the power cars were, adding 100 more passengers, while keeping the same weight. Less wasted space and less wasted energy.
So what you can see here is a 3D model of the AGV power bogie.